The moment you enter into a domain of research, you need to shift your gears from subjective and qualitative description to objective and quantitative description. So this is one aspect of science. It is also one aspect of being an excellent professional in whichever field you are doing. In 11th standard, you will see that if you are good at numerical ability, either in physics or chemistry, you immediately score more marks. Some students are there, they are afraid, they can write descriptive thing very nicely, they understand. But the moment mathematical section comes, numerical section comes, they ignore that section. And that is the group of students who lose lot of marks. So develop the familiarity with the number games. And I am going to share with you the number game of water. As Madam was mentioning, that this is the reservoir of water, total water. Now, see, you did, for a good researcher or a person who comprehends the thing, there are two types of students. One category of students who can mug up the numbers up to 6 decimals. I do not wish you to mug up the numbers up to 6 decimals. I wish you to conceptually understand and describe those things in quantitative terms. It will help you in writing your 11th standard papers also. When you are studying some topic, if you develop that tendency to quantitatively visualize, it will help you. Take it from me. So basically, about 97% of water is in the ocean. It's saline water, which you cannot use. About 2.5% of water is on the land. Again, not all of that you can use. And very small percent of water is there in the atmosphere. So this is the total water on earth. Okay. For our concern, for drinking water kind of concern, we are thinking about the water in this reservoir. And for hydrology cycle related concern, we are talking about the water from this reservoir. So next, what I am going to show you, the quantitative numbers in each segment of hydrological cycle are related to what arises from this 97% of water which is there on earth. At any stage, if you feel strange, you cannot understand something, please do ask the question. Otherwise you will keep on going with that uncertainty. Now please pay attention that whatever water is there in the ocean, from this water 503 units of water evaporate. Now what these units are is given here. It's in terms of 1000 kilometer cube of water. But for visualizing what I am going to tell you, you just focus on this number. Forget for the time being about what is the unit of this number. You visualize that 503 units of water arise from the ocean. Of these 503 units, 458 units fall back in the ocean itself. Okay, so the hydrological cycle, the major amount of water arises from the ocean, but nearly 91% of the water falls in the ocean itself. It never comes into the terrestrial region. So all great hydrology, all water resources problem, or hydrological dynamics that we are referring to is only related to 9% of the water which comes from the oceanic region. So about 45 units of water come from oceanic region into the land area. Now, what is the total precipitation which occurs in the terrestrial area? The precipitation is 119 units. Please try to compare the numbers. That the precipitation which falls on the land is 119 units of precipitation. How much is water coming from ocean? 45. So if only 45 units of water is coming from ocean, how come the rain is 109? Yes, the evaporation from land is a huge amount. You may say that, sir, what is the significance of this statement? You are making some statement. What is the significance of this statement? The significance of statement is that common man, a non-professional, believes that the way we use the water, say for irrigation, for distributary canals, it doesn't have a big impact in the hydrological cycle. Whereas the point which I want to convey is that the water which evaporates from the landmass is a big component of the hydrological cycle. Okay, it is that water which eventually mixes with the water coming from the ocean, and these together give rise to the precipitation on the land. And in this context, you have to also view the information about the water efficacy. See, drip irrigation, sprinkler, see, irrigation scientists are telling about this. Now, at that time we don't understand what is the significance of this. The significance lies here, that whatever water you sprayed, that water eventually evaporates. And therefore, the way we spread water on the land has to be very careful. Now here again, some number game. This number game will give you some feeling of criticality of water resources. Now in this case, you have to begin with this number, that 4,000 kilometer cube of rain falls on the Indian landmass. Okay, 4,000 kilometer cube of rain falls. Of this 4,000 kilometer cube of rain, about 47% of the rain flows into the river. Okay, 11% of the rain goes underground. It recharges the groundwater, and 42% of precipitation evaporates. Imagine that nearly 1,699, 1,700 kilometer cube of water which falls in the form of rain actually evaporates. You can do absolutely nothing about that water. So you are left with only this much of water. This unit of water in the river and this unit of water which goes underground. Now, strange thing is, this unit of water which is there in the river, all of that water you cannot use again. There is a limitation on that. So of this unit of water, there is 1869 units of water. The utilizable water is only 690. Why only so much of water is utilizable? Why rest of the water is not utilizable? Yes, rest of the water is not utilizable because you need to leave some water in the river so that river remains fresh. You need to leave the water in the river for ecological requirement, for environmental requirements. And second thing, you need to have large number of reservoirs in which you need to store the water. So it is difficult to have that many number of reservoirs. So you cannot use all that water which is available. So actual utilizable water is much less than the water which flows into the river. Of course, in case of groundwater, you can utilize large amount of groundwater. So we, out of these many units, we utilize these many units. We can utilize these many units. Out of these many units, we can utilize these many units. So basically, utilizable water is about 1100 kilometer cube. This is where the politics of water, dynamics of water, and economics of water begins. From there it arises. Those of you who are not going into the basic research, those who raise your hands that we want to become engineer, for that engineer also, in the next decade, he will have to be clear about what kind of things are. So, utilizable water is about 1100 kilometer cube. Of 4,000 kilometer cube of water which falls, eventually we are left with only 1100 kilometer cube of water. And unfortunately, of this 1100 kilometer cube of water which we can utilize, we are able to utilize only about 700 kilometers. Why? Because you need to have all the dams which we had planned. Dams should be constructed, canals should be constructed. If all the canals are constructed, then only you can transfer the water from one region to another region. So if that canal is not ready, if that reservoir space is not ready, all this water which is utilizable cannot be utilized. So currently we are utilizing about 700 or 750 kilometer cube of water. Now, there are projections that how much water will be required because population is increasing. So there are projections. These projections tell that projected requirement of water in 2050 will be around 1450 kilometer cube. 1450 kilometer cube. Currently, how much we are using? 7. 2050 means how many years from now? Okay. So around 35 years, we will have to develop this or meet this strong shortfall of water. To meet this shortfall of water, all engineered interventions will be there. Mathematical modeling of water resources distribution will be there. People are already working, but basically nation will have to achieve this target and generate the water of about 1400 kilometer cube in next 25 to 30 years. And why this is required? Because you cannot say that, okay, there is no water availability, we will restrict our development. Nation has to develop. One more, yes, please.
Sir, how you calculate all this data?
Very good question. The way it is calculated is that from water agencies, Central Groundwater Board or Ministry of Water Resources, there are data available about the river flows in various river basins, the groundwater in different hydrological basins. So we have compiled, in fact this data is based on one of our research paper which was published 6 years ago, in which we compiled this data. So you have to get the basin-wise information about the availability of the water, rainfall availability, and then you have to take into consideration the projections of population. There are population projections available, so which we will discuss in the next slide. And then you have to calculate many other things. What I am presenting is the simplest version, but actually when we do actual calculation, more involved and intricate aspects are considered. That how much of recharge will take place, how much of irrigation return flow will be there, how much of evaporation will be there. So this is how we compute. Thanks. I appreciate it. Do ask the questions. Now another thing. All of us are aware, વસ્તી બહુ વધી ગઈ છે. If you ask someone કે પાણીની તકલીફ કેમ છે, વસ્તી બહુ વધી ગઈ છે. Actually, વસ્તી વધી ગઈ છે is not the issue. What is the issue? Issue is that the population has increased dramatically in last 150 years. That is what is causing the problem. Had this been a gradual increase like this, then the societies, civilizations, technologies would have slowly adjusted to the evolving situations. This situation has generated quickly in last 200 years. And then system has to develop, system has to evolve the strategies to meet the increasing water demand. So more important than the increase in the population is the rate at which the population has increased. So it has suddenly increased. Second thing is that the projections which are available, that the way the population will rise, the water demand will also vary accordingly. In whichever way the population increases, whether there is a low growth rate, medium growth rate or high growth rate, the water demand is going to increase in next year to come. Now these are the sector-wise water usage. You see how the water usage for the agriculture has increased from say 1900 to 2000 and the projected demand. So the water demand for agriculture has increased, water demand for domestic use has increased, water demand for industry has increased. From this graph, what I want to show you is that the availability of the water, equitable distribution of water will affect or will govern the agricultural produce of the country, our comfort level of the country and the industrial growth of the country. Even for industries, you need huge amount of water. So our normal perception is that water means drinking water. It's not the case. You have to think about the water for agriculture, domestic and industrial use. So in the scientific perspective, the thinking is inclusive and we take care of all these aspects. Now we come to the challenge. What are the challenges? The challenge is that we need to provide the water with increasing water demand, but with two conditions. Okay, you can provide the water, but that measures of providing the water has to be economically and ecologically sustainable.